I'm going to use this platform itself and tell you what the formula will look like. So it's very obvious now to you that the P here is $24. But remember when? It's 1626, right? And R is 6%. Remember, it's per year. So two things to remember about R. It always is for a period of time, in this case a year, and it's always a percentage. I'm asking the following question. What is the future value in 2012? Everybody on the same page? Yes? So I'm going to now, you write, I'll talk. The future value will be 24 multiplied by 1.06, which is the one period factor, future value factor, raised to power, not multiplied by, raised to power the number of years that have gone between 1626 and 2012. And I think if I have that right, it's 386 years. So now this, if you can do in your head, it's pretty cool, but largely useless in my book. Okay, so let's try and do it with the calculator now that we have a machine that's dumb, and we can beat it up once in a while to give us things that we can't calculate too easily. So let's do this. We'll use the same formula, and let's see how to change it. The first thing that we encounter is the interest rate. So 0.06. Did I get that right? No, I sorry about that. Just give me a second. There's always, okay. So 0.06 is the interest rate, and the number of periods was 386. While you're doing this or while I'm doing this, try to guess the answer. If you do, you're a genius. Okay. And how much money was put away? Remember, no PMT, no inflow between these 386 years. So all we are having is the initial good old $24. Did I get that right? 6%, 386, $24. Okay, so let's see what happens. This, by the way, has so many zeros in it that I lose my mind right there. You know, I always forget how many zeros in a million, billion. Stuff that you can get from Google, you shouldn't put in your head, is my philosophy. But it's about $140 billion. 24 bucks has become $140 billion. Let me just show you how things change. So, for example, if I just took away 2 years from here, right? I just made it, what would it have been in 2010, which would be 384. Guess what happens? It's $125 billion. So what has happened in the last 2 years? You added $15 billion. Why? Because you've earned interest on interest on interest for a lot of years, but the pool of money you have after 384 years is so big that the next 2 years just add another $15 billion. So while this is very interesting, while it's a very interesting problem, I also want you to recognize it's not completely unheard of. In other words, it's not an unreal question to ask, is if this money had been put away, how much would they have? Of course, the much more interesting problem is the following. How much is Manhattan worth today? So I'm not going to get into that. That's an entirely different question to ask, but it gives you a sense of what I was trying to get here. And what I'm going to do now is I'm going to take a little bit of a pause. I'm going to let you think about what we have done. I would highly recommend, if you haven't taken a break till now, to take a break right now. Do two things. Do yoga, if that's what makes you happy. Bring coffee, smile, be happy, just revisit especially the last couple of problems and try to familiarize yourself with both the concept and the technology. Because I'm a big believer, if you do it on the fly, it just sits with you. If you postpone it to later, and I'm not asking you to start the assignment right now, right? That's a totally different animal. I'm asking you to just revisit quickly, take a break, and what I'm going to do is I'm going to do one more concept today, which is present value, and then we'll stop for this week and we'll move on to more interesting problems still involving time value of money next week. Okay? So take a little break, we'll come back. Thank you.